Hi everyone, this is Nuno Santos and today's video is about the Cartesian coordinate system. Now, the objective of today is to learn the basics of how to understand a graph and to understand how to use this system to represent them. So we can represent points in a plane as a two-dimensional space by using what we call the Cartesian coordinate system, which we construct as we can see over here. Now, to build it, it's quite simple. All you need is two lines that are perpendicular to each other. That means that they have a 90-degree angle in between them, okay, like over here. And out of this system, we define normally the horizontal axis as the x-axis, and that's why we put here an x, and we define the vertical axis as the y-axis, and that's why we put here a y. Now, one of the important things is that to know that the point at which these two lines intersect, we call it the origin. The origin basically means that both coordinates of this point are 0, okay, and you can see the origin as being the place right here. Now, with this, we understand the basics of this graph, and we can go to the next step of how to draw actually points on it. The horizontal line is therefore called the x-axis, and the vertical line is called the y-axis. Now, we have to understand that we place a scale along this line in order to help us measure the numbers that we want to mark in the scale. Now, what is important to know is that along the x-axis, positive numbers, okay, positive numbers lying to the right of the origin, and this is very important, are positive, and negative numbers will be lying to the left of the origin, okay? So it's very simple to understand. To the right, numbers are positive. To the left, numbers are negative when it comes to the axis. We can do the same thing, but for this time, the y-axis. Now, in this case, positive numbers are lying above, that means up the origin, okay? And negative numbers are lying below, and below means down the origin. Now, the number scales on the two axes don't need to be the same. For example, I might have on the x-axis, the scale might be going 1, 2, 3, 4, but for example, in the y-axis might make more sense to do 5, 10, 15, or 20. That really depends on what you're trying to do. You have to adapt the scale according to what your need is. Now, note the zeros of both number scales always coincide in that origin that I marked before. And by knowing that, we know that that spot, doesn't matter the scale you use, it will always be the origin. It will always be coordinate 0, 0. So how do we represent a point in this system? Basically, you can represent a point in the plane by what we call an ordered pair. And we call it an ordered pair because the numbers show up in a specific order. They show up as a pair, as you can see over here. So the first number will always be the axis, and the second number will always be the y. And that means that even if I gave you an example, for example, 1, and then a 2, I apologize for my handwriting on the computer, I know that my 1 is the x-axis and my 2 is on the y-axis because the 1 is on the left and the y is on the right. So to see this, let's imagine a point P, okay? And point P is a random point that has for coordinates x and y. And for this case, I'm assuming that x and y are positive. So I'll mark on my x the distance. Okay, so the distance x is here. And then I would mark on my y the distance, which is here. And these two lines coincide on this point. So this point would be my point P that has coordinates x and y. So here you have a small explanation how you do this, but I'll explain one more time just to make sure. So we would draw a perpendicular line to P, from P to the x-axis and to the y-axis. Then the number x is precisely the number that corresponds to the point on the x-axis at which the perpendicular line through P crosses that axis. Basically, what I'm saying here is what I just told you, right? In order to find that point, I know that that point is denoted on an x and a y coordinate. So I have to find them first in order to be able to place the point on this system, okay? We will do then the exact same for the y-axis, and conventionally, we give this ordered pair, xy, with x as the first number and y as the second. Why is that? Because basically it was defined that it would always be like that. If you wish, it's like a mathematical law, okay? It's a rule. So the point P in the plane is always uniquely determined by that. There is only one point in this plane that would have the coordinates, for example, 1 and 2 again. Only one possible point can have this. All right, so this slide I'm just skipping because basically I just explained what I wanted to do. So I'm just going to quickly skip it. There you go. So now continue our explanation. We see that y-axis, okay, this pair of points, the x can also be called the abscissa, okay, or the x-coordinate. To be honest, abscissa is quite a hard word to say, so I prefer to call it the x-coordinate. Y can be called the ordinate or the y-coordinate, and the same I prefer to call it the y-coordinate because it's easier for everyone. Now, x and y together are referred to when we see the two numbers together, we call them coordinates. And they are coordinates because they basically give us a specific point in the space. So here's some quick examples. I have a point P, which is denoted by numbers A and B. And I denote this point with the x-coordinates A and the y-coordinate B. So let's plot the following points. Okay, let's start with the point A, 2, 3. So what I will do is I will find my point x equals 2, which is here. I'm going to represent for this point in red, and y equals 3, which is here. And I will intersect these two lines, the perpendicular lines, they intersect right here. And that's when I got my point. Now I'm going to do another one in orange, for example, the point -2, 3. Okay, so -2 means that my axis would be to the left. So 1 and 2, here it is. And 3, okay, and 3 means that the point would be a positive y-axis. So I'll measure 1, 2, and 3. I'll intersect these two again, and I'll have my point B, -2, 3. So, other points of interest here. Let's do a couple more. For next one, I'm going to use yellow. All right. And I have the point -2, -3 over here. Perfect. So -2, -3 means that I would have to go -2 to the left, -3 is down. And again, they intersect here. So, to conclude, we can see one thing. I'm going to just erase all of them. We can see one thing. When the two coordinates are positive, they would have to be located in this area. When the two coordinates are negative, they would have to be located in this area. Okay? Now in green, when the x-coordinate is positive but y is negative, they are located here. And finally, in red, when the x is negative but y is positive, it's located in this area. All right? So with this, we understand where points are located. Another thing that is important to know is, let me just pick up my red color, here we go, is that whenever a point has a coordinate 0, that means that point is located in one of the axes. So this one has an x of 0, and therefore that's why it's located on the y-axis. You see, any point in this line over here always has an x of 0. And any point in this line over here always has a y of 0. So, as I mentioned before, the fact that in general my 2 points is always different, if I have xy, is different from having the same number here and the same numbers here, but inverted, we clearly illustrate that what we had in the previous points. Now, another thing that I want to say is that actually what I was explaining about positive and negative is again described over here in this graph down here. Okay? Now, the quadrant where, oh, by the way, each one of these massive squares over here, this we call it a quadrant. Okay? This one is called quadrant 1 because both coordinates are positive. All right? Now in orange, this one is called quadrant 2 because the x coordinate is negative and the y coordinate is positive. Quadrant 3, which I'm gonna now use blue. All right, quadrant 3, this one, remember both of them are negative. And finally, quadrant 4, this one, positive x, but a negative y. So now that we understood the basic concepts of how to do the graph and how to plot out specific points, okay, it's time to understand how does the distance formula work. All right, so let's suppose we have this example. We have 2 points, x1, y1. By the way, this does not mean that the coordinate is actually 1. It's whatever number, all right? And now let's imagine we have another point called x2, y2. These are 2 random points. Doesn't really matter if they're both positive or any of them is negative. Doesn't matter. Now, they are any 2 points in the plane, as we can see in the image over here, okay? Now, what I'm curious to know is, what is the distance between these 2 points? If the first point is over here, and the second point is over here, what would be the distance of the straight line between them? So the distance formula, it shows up on your screen right now. Then the distance between the 2 points can be computed by using the following formula, okay? And that formula is this one. So d, that represents the distance between 2 points that have coordinates x1, y1, x2, y2, the formula states that the distance between the 2 points will be the square root of x2 minus x1 squared plus y2 minus y1 squared. It's a very simple formula, and I recommend you to always write it down next to the exercises of this chapter because you will be doing them a lot. Another example we have here is, let's imagine that I have a point xy, and this point denotes a point that is lying on a circle that has a radius of r, okay, and the center in point C, and that's called, that center coordinates h and k, okay? So here we have at the center my point, the distance between this point and the random point called P, and I'm calling this distance R, okay? So what I want to know is the following. What is actually the relationship between X and Y? Is there any? Now, if we pick the formula that we just spoke, the distance formula. Now, by definition of a circle, the distance between my center, which is denoted here underneath red, and my point P, which is in purple, would be R, okay? Would be this number, R. So I know from looking at the previous example that the distance between these 2 points is R. And I also know that the distance formula that I gave you 2 slides ago can be rewritten to this. What am I writing here? I'm basically writing that the first coordinate, x1, minus the second coordinate, in this case it's h, okay? H from my point C, that is right here, squared plus y minus k, okay? Y is my point from P, k again comes from my C point, squared. This would be equal to the distance between the 2 points. Now, in this case, the distance between the 2 points is my point R. So I can just rewrite the formula into this state that you see here. Now, upon squaring both sides, if I square both sides, okay, in other words, what I can do, let me just quickly do this, is the following. If I come here, and I close this, and then I put a square, this is a really bad square, and then I go here, and I also square, this is completely normal to do. We can square both sides, and the formula would still be correct. So after squaring, what happens? This square over here eliminates my square root. And why? Okay, because when I have any number or any expression, and I have the square root of that, this is the same as having a power to 1 over 2, correct? Now, if I square it, if I go to a, that is powered to 1 over 2, that is powered to the square. Remember, when I have a number powered like this, power to the power, I multiply both of them. 1/2 times 2, this would be equal to a power 1. In other words, a square always eliminates the square root. And that's why now I eliminated the square root and I just rewrite what was inside square root, and now r is also squared from the previous step. And that must be satisfied, as you can see, by squaring both of them. Now I have an equation that is satisfied by x and y. So, by summarizing this, what do I get? I basically get what we call the equation of a circle. You see, this formula tells me every point that is away a specific distance, in this case r, from the center of the circumference, in this case coordinates h and k. And this is the formula for a circle. You see, a circle is nothing more than a collection of points that are all at the same distance from the center. And with this formula, I now have a way to calculate any of those points as long as it is a circle.